Hello students, this is my third lecture on equilibrium of coplanar forces. In first two lectures, we covered theory related to the equilibrium chapter, as well as we covered many problems on type 1, that is equilibrium of concurrent force system. This is the third lecture of the topic. We'll cover here type 2 problems, that is equilibrium of parallel force system. We'll also cover few problems from type 3, that is equilibrium of general force system. As already discussed in type 2 equilibrium of parallel force system, we will apply two equilibrium conditions. If the force system is parallel to x-axis, we'll apply force equilibrium condition sigma fx equal to 0. If force system is parallel to y-axis, we'll apply sigma fy is equal to 0. And another moment equilibrium condition sigma m about any point A is equal to 0. Let's move to the problems as theory is already discussed. Find the reactions for the beam shown in the figure. You are given with the beam which is simply supported, right? Simply supported, these are reactions exerted by the simple supports BA and BB. There is a UDL of 10 kilonewton per meter. There are point loads. There is a UDL of 4 meter length, intensity 5 kilonewton per meter. We need to draw free body diagram of the beam. On the free body diagram, you can come on this side. Reaction VA and VB are shown. This 10 kilonewton per meter UDL is to be replaced by equivalent point load. So what will be that equivalent point load? As we understand from the resultant chapter, we can convert it into equivalent point load. How do we convert into equivalent point load? Intensity is multiplied by the length. 10 kilonewton per meter into 3, that is 30 kilonewton. Where does it act? At the center of the length. Center of the length means what? Its length of the UDL is 3 meter. So equivalent point load will act at 1.5 meter right of A, as it has been shown. 20 kilonewton will be taken as it is. After that, 40 kilonewton will also come as it is. This 10 kilonewton up will also remain as it is. Now, this 5 kilonewton per meter UDL is multiplied by the length 4 meter, 5 into 4, 40, and 40 kilonewton, 5 into 4, 20. 5 into 4 is, that is 20 kilonewton will act vertically down. Your free body diagram is ready. Can you see that all forces are parallel to y-axis? So we'll use first equilibrium condition sigma fy is equal to 0. Sigma fy is equal to 0 means upward forces will be equated to downward forces. I have taken upward forces on the left hand side, VA plus VB plus 10. Down on the right hand side, 30 plus 20 plus 40 plus 20. So you get one simultaneous equation, VA plus VB is 100. Now we have to apply moment equilibrium condition. Normally moment equilibrium condition we applied, select the moment center in such a way that certain unknown will go off and some other unknown will be arrived at. So here ideally there are two moment centers, convenient moments. One is A. If I take moment about A, then VA will go off, VB will be arrived. If I take moment about B, then VB will go off, VA will be arrived. So anyway, you don't need to apply both the equilibrium condition, you need to apply only one. So we decided to apply sigma MA is equal to 0. Sigma MA means what? Algebraic sum of the moment of all forces about A is 0. When I'm taking sigma MA, all right, so then VA will go off. All downward forces on the right hand side will give you clockwise movement and upward will give you anti-clockwise movement. Your unknown is VB. So VB will give you anti-clockwise movement. VB into 10, that is anti-clockwise. All right. And 10 into 8, it is anti-clockwise, which we have written on the right side. On the left hand side, I have written clockwise movement. So 30 into 1.5 will give clockwise movement about A. 20 into 3 will give you clockwise movement about A. 40 into 6 will give you clockwise movement. And 20 into 8 will also give clockwise. So I have written clockwise movements on left side and anti-clockwise movements on right side. There is only one unknown in that is VB is arrived at 42.5 kilonewton upward. Substitute the value of VB in equation number 1. You'll get the value of VA, that is 57.5 kilonewton. This way the reactions are arrived at. This free body diagram of this beam becomes example of parallel force system, and that too the force system is parallel to y-axis. All right, let's move to the second problem. Calculate the reactions of the beam loaded as shown in the figure. This time you have a beam of length 10 meter. It is subjected to UDL and UVDL. First 3 meter is UDL. After that you have UVDL with intensity reducing from 2 kilonewton per meter to 1. Then for 4 meter. Then it increases from 1 kilonewton per meter to 5 kilonewton per meter, extending up to B. Now, you have to replace all these distributed loads by equivalent point loads. All right. It is again a simply supported beam. Simple supported reactions are VA and VB. This is in the free body diagram of the beam. VA and VB are marked. After that, now you can take this distributed load into three parts. Can we take this 1 kilonewton per meter? I can extend this dotted line right up to this. You can see that this is this way. This way we can extend this dotted line. Then you have the UDL of 1 kilonewton per meter, which is acting over 10 meter per 10 meter length. So this is first replacement. What I have done it 1 into 10 is 10 kilonewton, which will be at 5 meter from each side. So this is method done with this rectangular part of the loading. This 1 kilonewton per meter. This is the rectangle. After that, you come to this triangle. This triangle intensity is 0 at right hand and 1 kilonewton per meter on the left side. What will be equivalent point load due to triangular loading? Arrows are downward. Equivalent point load will be downward. What is area of triangle? Half into 4 into 1. This is 2 kilonewton. Where does it act? At the centroid of this triangle. Centroid of this triangle is what is B by 3, 4 by 3. Done. After that, you come to another triangular loading. This triangular loading is having intensity 0 on this side and 4 on this side, not 5. Why 5 is it is not? Because we have already used 1 kilonewton per meter in forming the UDL, rectangular loading. So this area of this triangle will be half into 3 base width and height is 4. So half into 3 into 4, that is 6 kilonewton. Where does it act? 3 by 3. So this way the free body diagram is drawn. Again, it becomes example of parallel force system. We'll apply first equilibrium condition. Again, all forces are parallel to y-axis. So we'll write sigma Fy is equal to 0. Upward is equal to downward. What are the upward forces? VA and VB. What are the downward forces? 10 plus 2 plus 6. So it becomes 80. Then we take moment about A. Algebraic sum of the moment all forces about A. A is this point. A is this point. All right. Now we take moment about A. So you can see that this 10 kilonewton is at 5 meter. 10 into 5 is clockwise. This load of 2 kilonewton is at what distance? 3 plus 4 by 3. 2 will also give clockwise moment. 2 into 3 plus 4 by 3 will give you clockwise moment. Then this 6 kilonewton will also give clockwise moment. What is that? This equivalent point load is 6. Down on the right side will give clockwise moment. This is going to be 3 plus 4, 7. 7 plus 3, 10. 10 minus 1, 9. So 6 into 9. That is giving you clockwise moment. VB into 10 will give anti-clockwise. All right. These clockwise movements are written on the left hand side about A. Anti-clockwise movements about A are written on the right side. That gets you the value of VB. And then this value of VB is substituted in equation number 1. We get reaction VA. So VB comes out to be 11.27 kilonewton and VA comes out to be 6.73 kilonewton. All right. We understood how to select movement center. We should also understand how we get clockwise movement or how we get anti-clockwise movement, although we have discussed it at length in resultant chapter. When you take suppose movement about A, when you take movement about A, you should see that you can assume that you are keeping a pencil or a pen at A perpendicular to the diagram or perpendicular to the page, and assume that this bar is free to rotate about an axis through point A. So you will see that 10 kilonewton will try to rotate the beam in clockwise, so movement is clockwise. 2 will try to rotate this beam in clockwise direction, so movement is clockwise. 6 will try to rotate in clockwise, the movement is clockwise. Whereas VB will try to rotate this beam in anti-clockwise, the movement is anti-clockwise. This way we. Let's move to the next sum. Problem number 3. Two smooth circular cylinders of weight 500 Newton each and radius r is equal to 150 mm are connected at their centers by string AB. This is your string AB connecting the centers of two spheres A and B. Length of the string is 400 mm and rests upon a horizontal plane supporting above them a third cylinder. Third cylinder is supporting by the other two cylinders for which the centers are connected by string of length 400. Above them a third cylinder of weight 1000 Newton and radius 150 mm. As shown in the figure. Radius of all the three cylinders is same 500, 500. But middle cylinder, its weight is 1000 Newton. Middle cylinder weight is what is 1000 Newton. Find the force in the string. Force in the string means tension in the string. Pressure produced at the points of contact D and E. Pressure produces nothing but, in talking terms we say pressure, but actually it is reactions. What it is? Reaction. So he is looking for reaction at D and reaction at E. Now students, let's understand about three cylinders are given to you. Middle cylinder is kept on the lower two cylinders. We have solved this type of problems in type 1. We can solve this problem also in type 1. We can find the inclination of the line joining the centers, and then we can separate out all the three cylinders. We can separate out all the three cylinders. FBD of each cylinder will be example of concurrent force system. We can find all unknowns. So this problem can be easily solved in type 1. But I have kept it intentionally in type 2. Now, why? So I'm asking you to take the free body diagram of the three cylinders as one unit without separating. You are taking FBD of three cylinders as one unit. All right. This is what I have taken it up. Now, see the what change will come. Weight of three cylinders will act vertically down, 500 Newton, 500 Newton, 1000 Newton. I have shown it at the centers. Reactions will be obviously upward. RD is at D and RE is at E, right? Now, does it become example of parallel force system or not? FBD of three cylinders as one unit will become example of parallel force system. Understand it here. See, tension in the string will not come into consideration. Tension in the string AB will not come into consideration because tension in the string comes into consideration only when string is cut. We have not cut the string. All right. Next is going to be reaction between the two cylinders. Reaction between cylinder A and C will not come. Reaction between common reaction between cylinder C and B will also not come into consideration because you have not separated the cylinder. You should understand that common reaction between two circular bodies will come into play, come into existence, come into consideration only when they are separated. We have not separated cylinder A and C. We have not separated cylinder B and C. So common reaction will not come into consideration. This is what is the conceptual part which we all need to understand. Anyway, now it is a parallel force system. So first apply sigma Fy is equal to 0. Upward is equal to downward. Rd plus Re is equal to 500 plus 500 plus 1000. So you got Rd plus Re is equal to 2000. Now I have to select the moment center. Selecting the moment center, obviously I take D or E. I've taken sigma Md. When I take sigma Md, 500 and Rd are passing through D, so their moments will be 0. All right. Then 1000 should be assumed against D. 1000 into 200 clockwise. 500 into 400 clockwise, Re into 400 anti-clockwise. This gets you the value of R, 1000. Substitute the value of R in equation number 1, you get the value of R. So this way, students, from this free body diagram, you got RD and R. But my question is that, can we get the common reaction from this FBD? No. Can you get the tension in the string from this FBD? No. So tension in the string and common reaction between the two circular cylinders cannot be arrived from this free body diagram. Because you can find the unknown only when the unknown is reflecting in the free body diagram. So unknown tension in the string is not reflecting in the free body. Now there is another way also to get the reaction RD and R. This is due to symmetry. Because advantage of symmetry, we can always take it in many problems of mechanics. Like in this problem, assume that you have two palms. One cylinder is kept on one palm, another cylinder is kept on the one other palm. Exactly midway you have kept the third cylinder. All right. So what pressure will come on two palms due to symmetry? The pressure on two palms will be equal or not? And what is that equal to? Total weight of the system divided by 2. So I have written it at the bottom. If you can see that, I have written it here about also due to symmetry, RD plus R is equal to RE is equal to total weight of the system divided by 2. Total weight is what? 500 plus 1000 plus 500 divided by 2. That is 1000. Right. This is another way of getting the reactions. Now, if you want to find the tension in the string, as it is one of the unknowns, you have to split cylinder A from the system, or you have to split cylinder B from the system. If you split it, then tension in the string will come because that means you have cut the string, and common reaction between A and C. So we are deciding to consider FBD of cylinder A. We are deciding to consider FBD of cylinder A. All right. So then I have drawn the line joining the centers. Now in triangle ACF, you can get cos theta is equal to AF upon AC. In triangle ACF, you get cos theta is AF upon AC. AF is 200 and AC is sum of the two radii, 150 plus 150. So this gets the value of theta. Once you got the value of theta, you can draw FBD of cylinder A. When I draw FBD of cylinder A, weight 500 Newton will act downward. RD 1000, you already got it. Tension in the string will be away. You have shown it. Common reaction always acts towards the body. That's what we have shown at angle theta. We resolve that common reaction. at any point along its line of action on the tail side. This is r cos theta and r sin. Here you cannot use Lami's theorem, so you have to use sigma fx and sigma fy for the reason that there are four forces. We write sigma fy is equal to 0, rd 1000 is equal to 500 per r sin theta, that gets you the value of r. Sigma fx is equal to 0, t is equal to r cos theta. You get substitute the value of r, substitute the value of theta, you get tension plus 2. Again, I repeat that this problem could have been solved easily in type 1 also. But my intention of taking it in type 2 is so that you get the idea that common reactions do not come into consideration if you take the cylinders together. Also, I wanted you to understand tension in the string will not come into consideration if the string is intact in the system. String has not been cut in the system. All right. We move to the next sum. This is problem number 4. A heavy rod AB of length 3 meters lies on the horizontal ground. To lift the end B off the ground needs a vertical force of 200 Newton. To lift end A off the ground needs a force of 160 Newton. Find the weight of the rod and position of its center of mass. Well, in this problem, rod is lying on the ground. The heavy rod of 3 meter length is lying on the ground. When this rod is lying on the ground and end B is just lifted off. When you are just applying a force to lift off this rod, so what will happen? As you just lift it off, the entire rod will lose contact with the ground. So only point A will be in contact with the ground. Only point A will be in contact, or and A will be in contact. So there will be only vertical reaction. At A, there will not be any reaction. Obviously, the weight will act vertically down at the centroidal distance x or x bar. It is actually x bar I have taken, but here by mischance x bar is not appearing, but I hope you can understand it. So this is becoming the example of parallel force system. How you arrive at this example? End B is lifted off by 200 Newton force, entire length will lose contact. So no reaction between A and B. Only point and A will be in contact with the plane, so normal reaction will come at A. Now he is not asking BA, you can take moment about A. If you take moment about A, then W into X bar will be, weight will give you clockwise moment. This is X bar, read it X bar. W into X bar, as you can see here, and 200 into 3, 600. So you got W X bar is equal to 600, you got one equation. Now, other case, what he has mentioned that if you want to lift an A, you need a force of 160 Newton. Just to lift off the rod, you need a force of 160 Newton. When you have applied a force at A to lift off the rod, you'll see that entire length will lose contact with the plane except end B. So normal reaction in the second observation will come at end B. Again, we'll take weight, 160 Newton is external force. Weight is acting vertically down at distance x bar. All right. And VB will be the normal reaction. Again, VB is not asked, he is asking W and X bar, so I take moment about B. When I take moment about B, right, you can see the VB will go off. 160 into 3 is clockwise, W into 3 minus X bar is anti-clockwise. This is what is written over there. So this is 480. Open out the bracket, 3W minus WX bar. WX bar value has been substituted from here, that is 600. So you got W, and if you substitute the value of W in equation number 1, you'll get the value of X bar 1.667. Hope you understand. Now, we move to the next sum. It's on the same slide, problem number 5. This is also a very good sum. The conceptual part is to be understood. Otherwise, the working is simple. A uniform beam AB of weight W is equal to 100 Newton rests on the two roller supports C and D as shown in the figure. If a force of 250 Newton is applied to the end B, find the range of the values of force F for which the beam will remain in equilibrium. Now, please look at this beam. This beam is resting on two rollers. One roller is at C, another roller is at D. External forces which are acting on this is 250 Newton force is applied at B, and weight of this beam is acting at 20 centimeter from C and 30 centimeter from D. I mean in the middle. right? Total length of the bar is 1 meter. Now he is asking you to find the value of F. What should be the maximum value of F for that the equilibrium is maintained? Now you just see that, try to understand. Now in this case, the roller means what? The beam can be lifted off, or the beam gets lifted off. F force applied at end A will be maximum when? Force F, you keep on, see, assume that you are increasing the value of F. You keep on increasing it. A stage will come when F will be maximum at the stage when this beam will be lifted off from roller D. Beam will be, F will be maximum when the beam just lifts off roller D. So that means reaction BD will be 0. In that case, F will be maximum when the beam loses contact from the roller and it just lifted off. So it is BD is 0. So I have written it. BD is 0 since beam will be just lifted off D. So sigma MC is equal to 0 when you take it. You will take clockwise movement 100 into 20, 250 into 70, and F, these are clockwise movements, F into 30 will be anti-clockwise. So this gets you the value of 650 Newton. So when a value of F is 650 Newton, the beam will just lift off at D. So VD will be 0 because beam will lose contact with the road. Now, second case is of F minimum. F minimum is what you want, minimum value F for the equilibrium condition. See, comparison of F will be with 250. So in comparison to 250, F should be very small. You keep on reducing the value of F. A stage will come when this 250 Newton will lift off the beam from roller C. The beam will be lifted off from roller C. I'm again repeating, F will be minimum when value of F is so small that the beam gets lifted off from roller C. In that case, for F minimum, VC will be 0 because the beam loses contact with roller C. So I've written F minimum case, take VC is equal to 0. Since the beam will just lift it off at C. So this time you take moment about D. When you take moment about D, 250 into 20 is clockwise, 100 into 30 is anti-clockwise, F into 80 is also anti-clockwise. This gets the value of F. All right. So in short, we have understood that for the given beam, which is resting on the two rollers, F will be maximum when beam just lifts off at D, so that VD is 0. And F will be minimum when F is so small that beam gets lifted off at roller C, so that VC will be 0. So this is what is the conceptual part of this sum. All right, students. Now, with that, type 2 problems are completed. In the examination, they rarely ask the problems on type 2. Most of the time, problems come from type 1 and type 3. Most of the time, the problems come on type 1 and type 3. So we are ready to start with the most important type that will be very commonly what we come across in the examination. You can be sure that there will be at least one problem from type 3 of this chapter. At times we come across that two problems will come from the type 3 of this chapter, that is equilibrium of general force system. So my type 3 is what? Equilibrium of general force system. This, what are the three equilibrium conditions as already discussed? Sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. Sigma fx is equal to 0 means algebraic sum of all the forces along x-axis in x direction will be 0. Sigma fy means algebraic sum of component of all forces in y direction is 0. Sigma means algebraic sum of the movement of all forces of the system about any point A is 0. All right. Now, in this lecture, we'll cover a few problems from general force system, that is equilibrium. That many more problems I'll be covering in the next part, that is part 4 of this chapter. As I had already discussed, this chapter is most important chapter of the subject, right? That's why I am covering maximum number of problems in my lectures. That's why this chapter has been splitted or divided or covered into 4 parts. There is no other chapter which is covered in 4 parts. Most of the chapters will be covered in 2 or 3 lectures of mine. All right, students, we start with the problems. First problem of this type: determine the reactions for the beam shown in the figure. You have a beam which is shown to you. you have to find the reactions. Now you can first see that at this beam is supported at A by hinge. I hope you understand the notation of hinge. And at B, it is supported by a roller. Hinge exerts two reactions, one horizontal, one vertical, and roller exerts one reaction normal to the surface on which roller rests. Now we draw the free body diagram of the beam. First see that hinge will be replaced with two reactions HA and BA. Direction of HA and BA are assumed. Then roller will replace with one reaction. Roller is resting on horizontal plane. Reaction will be normal. That is 16 Newton is the external load. That is 16 Newton. This is just shown kilonewton. It is 16 Newton. This triangular load will be converted into equivalent point load. What is arrows are downward? Equivalent point load will be downward. What is equivalent point load? Area of triangle. What is that? Half into 3 into 12, which comes out to be 18 Newton. Where does it act? At the centroid of this triangle. Center of the triangle means 3 by 3 from this end. All right. So this is 1 meter from this part and 2 meter from this end. So 1 plus 2, this is 2 at 2 meter from 2 plus 1, 3 meter. 1 plus 2, that is 3 meter from end A. So this is 18 Newton has been shown. At what distance? It is at 1 meter from this side. So all distances have been marked. We can apply the equilibrium conditions. How many unknowns can be determined in the problems of general force system? 3. Why 3? Because 3 equilibrium conditions are there, so 3 unknowns can be arrived. Let's apply the equilibrium condition. Sigma fx is equal to 0. We get HA is equal to 0. Since there is no force other than HA in horizontal direction, then we write sigma Fy is equal to 0. Sigma Fy is what? Upward forces are equated to downward. VA plus VB is upward. What is downward? 18 plus 16. That is 34. Then we take movement about A. Normally in general force system, hinge is considered to be the convenient movement center. Hinge is considered to be the convenient movement center for applying movement equilibrium condition. Reason is very clear, because hinge exerts two reactions. All right. So if you take movement about hinge or you apply movement equilibrium condition about hinge, you'll understand that two unknowns will go off. And once the two unknowns will go off, third unknown can be easily determined. That's why we apply sigma M. When I apply sigma MA, you can see that HA and VA will go off. You can see that this 18 into 3 is clockwise movement. This is 16 into perpendicular is 1 plus 2, 3 plus 1, 4 plus 5, 6. Into 6 is clockwise. And VB into 5 is anti-clockwise. This gets you the value. VB is 30 Newton. And then if this value is substituted in equation number 1, you get the value of VA, that is 4. So this way the reactions are arrived at. Here I have listed some note which are already discussed, but again I'll just read all this note are important, should be observed when we are solving. First of all, you should understand direction the reaction exerted by the roller, hinge or fixed support are always assumed. Right? You are not sure whether HA will be to the right or to the left, VA will be upward or downward, VB will be upward or downward. Now, again, next point. What is next point? Hinge is considered to be the convenient movement center. For the obvious reason I have already discussed. Why it is convenient movement center? Because out of the 3 unknowns, 2 will go off and third one will be obtained. And third point, I have written that you can apply the equilibrium conditions sigma Fx is equal to 0, sigma Fy is equal to 0, and sigma Ma is equal to 0 in any convenience, any sequence you can apply as for our convenience. Whatever is convenient to us, we can apply that equilibrium condition first. It is not necessary that you have to start from sigma Fx equal to 0 or sigma Fy is equal to 0 or sigma M is equal to 0. All right. Now, with the understanding of all these important points, we start with second problem. It is on the same slide. You can see that second problem. Find the support reactions at hinge A and roller. You have the hinge at A. So there will be two reactions will be exerted by the hinge at A. There will be one reaction will be exerted by the roller at. We draw a free body diagram of the B. We replace the hinge at A with two reactions HA and BA. We have shown one reaction BB over here. Then this is the UDL. Intensity is 5 into 4, 40, 5 into 4 is 20. 5 into 4 is 20 kilonewton will act at 2 meter from each end. That we have marked. Again, I repeat, UDL intensity is 5, acting over the length of 4. 5 into 4 is 20, acts at 2 meter. 25 kilonewton has been marked over here. Okay. Then this part is like, a bracket which is attached to the beam. So you cannot detach it. Let it be as it is. Let it be as it is 1.5 meters. This 30 kilonewton load is at 40 degree, which is to be resolved, which we have resolved it 30 sine 40 and 30 cos 40. Adjacent is cos, other is sine. Your free body diagram, students, is ready. Your free body diagram is ready for applying equilibrium conditions. Let's start with sigma fx is equal to 0. When I start sigma fx is equal to 0, ha is to the right is equal to 30 cos 40. You get the value of ha. Then instead of applying sigma fy, I have started with sigma m. Why? Because sigma fy, if I write it, I get a relation between VA and VB. Whereas if I take sigma MA, HAVA will go off and VB will be arrived at. All right. So we'll start with sigma MA. I keep my pen or pencil at A. You see that HAVA will go off. This 20 will give you clockwise movement, 20 into 2. 25 into 4 is clockwise movement. 30 sine 40 is downward at a distance of 8 meters. 30 sine 40 into 8 is clockwise movement. Then this 30 cos 40, which is to the left, should be assumed against the movement center. Just pull it against the movement center to the left. So 30 cos 40 will give you anti-clockwise movement. It is at what perpendicular distance? 1.5. So 30 cos 40 into 1.5 will give anti-clockwise movement, which we have written on the right side. All right. VB is at 10 meter. VB will also give you anti-clockwise. VB will also give anti-clockwise. So VB into 10. 30 cos 40 into 1.5, these two are anti-clockwise. This way you get value of VB. Once you have 25.98 kilonewton, then substitute the value of VB. We have got VB. Right now, sigma Fy is equal to 0. VA plus VB upward is equal to 20 plus 25 plus 30 sine 40. Substitute the value of VB into the equation, you get the value of VB. VA and VB, while solving by using the equilibrium condition, both came positive. That means assumed directions are correct. So HA, VA and VB all have come out to be positive. That means their assumed directions were correct. Anytime while solving the problem, after solving the sum, if any of the unknown reaction comes out to be negative, it will indicate that assumed direction was wrong. So reversal of the direction will be taken. All right, ready to move to the next sum. Next, third sum. Finds support reactions at A and B. A is hinge support, B is a roller support. We have to find support reactions at A and B. A is hinge. We'll draw, of course, we'll draw the free body diagram of the beam. Normally in beam reaction type of sums, we need to draw the free body diagram of the beam. And you can draw the line diagram. You can draw the line diagram. So at A, we have shown the two reactions, HA and A. Then 1 kilonewton external load. 24 kilonewton is acting over 3 meter length. 24 into 3, 72 kilonewton, which will act at the center of the length, that is 1.5 meter from each side. 18 kilonewton meter is the external moment, which is to be taken as it is. 18 kilonewton meter external moment is to be taken as it is. Then at B, you have a roller. At B, you have a roller. This roller will exert vertical reaction as it is resting on horizontal plane. So you got it. Then this triangular load, arrows are downward, equivalent point load will be downward. What is area of this triangle? Half into base into height, half into 3 into 24. That comes 36 kilonewton, 3 by 3, 1 meter from right side and 2 meter from. So this way my free body diagram is ready. Once my free body diagram is ready, I'm ready to apply the equilibrium conditions. I begin with sigma Fx equal to 0. When I write sigma Fx equal to 0, there is no force except HA. So HA will be 0. That means horizontal reaction at A is 0. Then we have written sigma Fy, although here also I could have started with sigma MA. But here I have taken sigma Fy is equal to 0, upward is equal to downward. Upward is VA plus VB upward, downward is 1 plus 72 plus 36. All right, this comes out to 109. Then we take movement about A. When I take movement about A, HAVA will go off 1 into 1.5 clockwise, 72 into 5.5 clockwise, 36 into 11 is clockwise, VB into 9 is the perpendicular distance anti-clockwise, and this 18 kilonewton meter is also anti-clockwise, so it will be on the right hand side. Mind it that when you are taking a movement about any point, and if there is external movement on the beam, so movement is simply taken clockwise, anti-clockwise. No distance is to be multiplied with the movement as it is already. So on the right hand side, we took anti-clockwise one, VB into 9 and 18. Rest all the loads 1 kilonewton, 70 kilonewton, and 36 kilonewton have given you clockwise movement, which have been taken on left hand side. So this way we arrived at value of VB, which comes out to be 86.17 kilonewton. Then value of VB is substituted in equation number 1. You get the value of VA, which comes out to be 22.8. This type of problems, students, are very simple type of sums, very easy, very less time consuming, and mostly one problem on beam reaction will surely come in your examination. One problem on beam reaction will definitely come in your examination. And these are all basic fundamental sums, are quite important. And good part is that you'll get these sums for not less than 5-6 marks, and it goes up to 8 marks, as you can see that. This problem I have taken it from the Mumbai University examination of December 2015, and DJ Sangvi May 2018, and KJ Somaya also May 2015. In this way, 3 examinations, the same problem with the same data was asked. Okay, let's move to the next sum. Next is question number 4. I'm reading again it is a beam reaction type. Find the support reactions at A and B for the beam shown. You are given with the beam which is hinged at A, 2 reactions, and there is a roller at B, which is, we call it as, there will be 1 reaction. All right. So when we draw free body diagram of this beam, I'll show 2 reactions at A, HA and BA. Just slightly it is becoming a bit congested. HA is at A and this is B. Here we have shown अभी all these loads are to be replaced with equivalent point loads. अभी मैं क्या करूंगा, ये वाला जो triangle load है ना, उसको मैं left of A पकड़ लूंगा, ये वाला, right? You have to divide this UVDL into 2 right angle triangles. This is 1 right angle triangle, half into 1 into 10. So it comes 5 kilonewton, which will act at 1/3 meter left of. हो गया? अभी दूसरे पे आ जाओ, ये वाला triangular load. This is half into base 2 into 10. Half into 2 into 10, 10 kilonewton. It will be acting 2/3 from A. It will act at 2/3 distance from A. ये देखो इधर मैंने दिखाया है, ये वाला distance 2/3 यहाँ पे दिखाया है. अभी ये खत्म हो गया. अभी इधर आ जाओ, 12 kilonewton. 12 kilonewton is inclined at 30 degree. You need to resolve it. 12 sin 30 downward and 12 cos 30 to the left. खत्म. अभी इधर आ जाओ, ये this distance is 8 meter. Here 10 kilonewton. This trapezoidal loading, you can split it into rectangle and triangle. First is that if you draw a dotted line like this. All right. So what is the UDL in this part? So 10 kilonewton, a rectangle can be derived 10 kilonewton per meter of length, 10 into 8, 80 kilonewton, where which will act at 4 meter from each. Where will act 4 meter from each. Then you have a triangle. Triangle is a base with 8 and its height on the right hand side will be 10. Why 10? Because 10 is already used in forming UDL. 10, this total rectangle has been already used in UDL. So half into 8 into 10, that comes out to be 40 kilonewton, and it acts 8/3 meter from the right side. So this way my free body diagram is ready with all the active as well as reactive forces. All right. Now it is a general force system, right? You have to take apply 3 equilibrium conditions. Start with sigma Fx is equal to 0. HA is to the right, 12 cos 30 is to the left. HA is equal to 12 cos 30, 10.39. HA is positive, that means assume direction towards right is correct. Then we write sigma Fy is equal to 0, upward is equal to downward, VA is upward, VA plus VB is upward, is equal to 5 plus 10 plus 12 sin 30 plus 80 plus 1. List out all this. If you use your calculator, you get 141. So VA plus VB is 140. Then you have to take moment about A or B. I am taking moment about A. When I take moment about A, HAVA will go off. When we apply more, we take sigma MA is equal to 0, HAVA will go off. Even this 12 cos 30 will also go off. This 12 cos 30 will also go off because this 12 cos 30 is acting along the axis of the beam, so it will also pass through A. All right. Then now we start listing out. This 10 will give you clockwise movement. Right. In the notes I have written first anti-clockwise movement on the left hand side. So we'll talk about anti-clockwise. Okay. VB is at what distance? 11 meter. VB is at what distance from A? 11 meter. 8 plus 1, 9 plus 2, 11. Anti-clockwise movement. What else will give you anti-clockwise movement? This 5 will also give anti-clockwise, which is left of A. Right? 5 into 1/3 will also give you anti-clockwise, which we have taken. So anti-clockwise over. Now we come to the clockwise movements. This 10 into 2 by 3 will give you clockwise movement. 12 sine 30 into 2.5 will give you clockwise movement. 80 into 7 will give you clockwise movement. Even 40 into 11 minus 8 by 3. Distance between A and B is 11 meter, and this equivalent point load is at 8 by 3 meter from right of B. So perpendicular distance of 40 from A will be 11 minus 8 by 3. So this is what is going to be clockwise. So I have written clockwise movements on right side, anti-clockwise movements on left side. Students, it is always your choice. It is always your choice whether you want to write clockwise movements on left side or you want to write clockwise movements on right side. Whatever you decide, you need to follow. You have to take movements of one nature on one side, movements of opposite nature on the other side. So this gets you the value of VB. Once the value of VB is obtained, 83.03 kilonewton, it came positive, that means assumed direction is correct. Then value of VB is substituted in equation number 1, you get the value of VA 57.97. Oh, this is all being understood. I have kept a common capstone here, equilibrium conditions for general force system, sigma fx, sigma fn, sigma ma, which we have been using in all these sums. All right, we take the next sum. I read it. Find the reactions at the supports B and F. Find the reactions at support B and F. You can see that B is a hinge support. All right. So which will exert two reactions. On the other end, at the end, there is a roller at F. This point F is just missed out from there. Right. This is point F where there is a roller. This roller is resting on inclined plane. This roller is resting on inclined plane, which is making 30 degree with the horizon. Now, obviously, we will draw the free body diagram of this B. Hinge at B will provide two reactions. You can see that HB and VB. We have provided HB and we have provided VB. These are the two reactions have been shown. Khatam beta. Uske baad mein, you come to at point F. This point is F. I've listed here F. All right. Here there is a roller which is resting on a plane which is making 30 degrees horizontal. Roller will exert one reaction normal to the plane. And if the plane is making 30 degree with horizontal, reaction RF normal to the plane will make 30 degree with vertical. This is what I have written it also in the initial few lines. Let's draw FBD of the beam as shown. In the given figure, roller is resting on a plane 30 degree to horizontal. Hence, roller reaction RF normal to the plane will make 30 degree with vertical as shown in the figure. Then RF has to be resolved. We have shown RF. RF is making 30 degree with vertical. We have resolved it. Adjacent is cos, other is sine. Student, when you are in general force system, do remember that you cannot resolve the force anywhere on the line of action. You have to resolve the point force exactly at the point where it is acting on the body. So we resolved it at the point F, RF cos 30, RF. Matter is over. Then we come to replacement of the distributed force. This is 50 Newton per meter acting over the length of 5 meter. So 50 into 5 is 250 Newton, which will act to 2.5 meter from A and 2.5 meter from C. मैंने A से दिखा दिया. Rest all this 4 meter length has been shown. After that, you come to this 150 Newton. This 150 Newton force is at 30 degree. So we resolved it 150 sine 30 and 150 cos 30. And this movement of 150 Newton meter is external movement, which has also been marked or shown as it is. After that, you come to this triangular loading. This triangular loading is arrows are downward, equivalent point load will be downward. What is area of triangle? Half into base, that is 4 into 120. Half into 4 into 120, that comes out to be 240 Newton. And this will act at B by 3 from E, right? This is 4 by 3 from E. Because total length is, total width of the triangle is 4, so 4 by 3 from left hand side, which is 4. So this way, all the forces have been marked on the free body diagram. Let's start with movement about B. This time I have started with the movement equilibrium condition about B. So you are taking B as the movement center. So let's identify first what will go off. Students, HB will go off, BB will go off. Okay? Uske baad 150 cos 30 will also go off. It will also pass. Even RF sin 30 will also go off. Even RF sin 30 will also go off. Let's start. Sigma m. 150 sine 30 into 2 clockwise movement. 150 is external movement clockwise. 240 will also give clockwise. What is perpendicular distance? 1 plus 1 plus 1, 3. 3 plus 4 by 3. 3 plus 4 by 3, 240 will give you clockwise movement. All right. Then clockwise movements are over. RF cos 30 is at perpendicular distance of 7 from B. So it will give anti-clockwise. RF cos 30 into 7 will give anti-clockwise. And this 250 Newton force left of B will also give anti-clockwise movement. 250 left of B, we are taking sigma MB, right? 250 is at left of B, it will also give anti-clockwise movement. What is perpendicular distance? 1.5. How you get 1.5? 4 minus 2.5 is 1.5. So this way it gives you anti-clockwise movement 250 into 1.5. So this way, students, RF is arrived at 159.18 Newton, right? Roller reaction RF is making 30 degrees vertical. That means it is making 60 degree with horizontal. That's what we want. Then we write sigma fx equal to 0. You can see that HB is to the right, 150 cos 30. HB is to the right, 150 cos 30 to the left, and RF sin 30 is to the left. We write sigma fx is equal to 0. So HB is equal to 150 cos 30 plus RF sin 30. Substitute the value RF, you get HB. HB is positive, that means assumed direction is correct. Then we write sigma Fy is equal to 0. Sigma Fy is equal to 0 means what? Upward forces are equated to downward forces. What are the upward forces? VB plus RF cos 30 equal to downward 250 plus 150 sin 30 plus 240. Just substitute the value of RF, you get the value of. So this way, students, we have arrived at the reactions HB, VB, and RF. In this problem, the roller was resting on a plane which is 30 degrees horizontal. Reaction exerted by the roller will be at 30 degrees with vertical. In 5 problems, what I have taken in this lecture on general force system, all were of beam reaction type results, where we come across different supports like hinge rollers and all, different types of loads, point load, UDL, UVDL, external movements, and all that. We will be covering around maybe 10 to 15, 10, 12 more problems on the general force system will be covered in my next lecture. That will be part 4, and that is the concluding lecture of this chapter. That will be taken up soon. All right. And again, I repeat that this topic is very, very important. We have covered 3 sessions or 3 lectures of this topic already. One more is remaining, which will be taken up, covered up very soon. Also, again, I repeat that all these problems have been taken my book, all right, of engineering mechanics. You can buy the book from the local bookstore, or you can buy the book on Amazon also. We have arranged free delivery along with some discount. Like link of Amazon is shared in the video description. In every video description, it is shared, right? Book has many more solved problems. Book has few unsolved practice problems also. Book has many MCQs on every chapter. So it will be definitely worth if you buy the book also. I advise and suggest that please share the QR code of my video channel to your friends, so that maximum people are benefited from my video lectures. You can subscribe to my YouTube channel also, so that as and when the new video lecture is uploaded, you'll keep getting the notifications. Okay, thank you very much.